Hi, I'm Heather Weintraub, and I will be discussing the study on gluten-free diets for patients with Alzheimer's disease. In the first slide, I'll be talking about Alzheimer's disease, and the disease causes the brain causing dementia and cognitive disorders in the elderly patients. We don't know what causes AD, but we do know that it can be diagnosed by NFTs and amyloid senile plaques, which is visible in CT scans and MRIs. It's not everybody in the elderly, but it's all dementia patients, which is about 60 to 80%. Why do we care about it? Because Alzheimer's is on the rise, and the longer we live, the more likely we get AD, because AD is a disease that affects the elderly. We don't know where it comes from, but there are many debates as whether it is genetic or if it's a combination of genetic or the environment. Alzheimer patients affect both the family and it also affects the community, which is tragic to ongoing things that happen throughout, and it's a costly disease. What is gluten? Gluten is a substance that is found mostly in grains, wheat, and it's responsible for the expansion of dough. Celiac disease is also a disease that causes mild to severe illnesses in people with their digestion. Gluten has shown to effects of many parts of the body, from digestive to the brain, and due to proteins that can cause interactions. There are a few studies on gluten-free diet that have conducted for Alzheimer's patients, but there is literature shown that there's connection between the gut and the disease. In this next slide, I'm going to talk about the evidence in supporting these claims. The first study that is shown is that elderly patients have longer to diagnose and have much lower rate of diagnosis for celiac. So the point here is that many AD patients could have celiac, but we don't know because they're not diagnosed. In the second study that I came about, it shows that those with dementia had a higher rate of celiac, but unfortunately they did not find what was the case. This doesn't support my theory, but it also does not rule out gluten-free diets. Would not help. In the third study that I talk about, are proteins being misfolded by the gut, which can cause plaques and lesions seen in Alzheimer's patients. It does not talk about gluten again, but it provides a connection between the gut and the brain. In the fourth study, it's directly links with gluten sensitivity that inflames the brain, especially in the central nervous system, which we have problems in AD. In the last study, there's a lot of information to talk about, but it's not enough time in 8 minutes. But it provides many specific bacteria in the gut and how they relate to celiac disease contributed to Alzheimer's disease. Here in this slide is the research hypothesis and the null hypothesis. The research hypothesis is Alzheimer's patients on a gluten-free diet progress slower than Alzheimer's patients not on a gluten-free diet. And the null hypothesis is that Alzheimer's patients on a gluten-free diet progress at the same rate as Alzheimer's patients not on a gluten-free diet. Here's how we are going to test this. We are going on to test this by using the Dementia Severity Rating Scale, which is also known as DSRS. Patients are able to use this themselves, and there's a final score that indicates the levels of severity of the disease. The final scores start with a 0 to 18, which is mild, a 19 to 36, which is moderate, and 37 to 54, which is severe. We are going to stick with going to recruit patients that are testing as mild. So that is with a range of 0 to 18. Here is what I'm testing for in the patients, and I would test them in the morning about 10 o'clock. I would test them for as long as a year, once a week, and the test I'm going to use is a t-test. The reason why I'm using a t-test is because we are first assuming normally distribution data. If we find it is not normally distributed, we will then use a man-wit-u test instead. But for now, let's assume normal data. Second, the data is also independent, and we are testing two groups. There are two levels, and therefore the prior test is a t-test. Here in this slide is how many are in the study. Literature shows that in 1 year, the score dropped 4.5 points. For the statistical significance, we need a difference of 2 points between the groups. We are only recruiting patients who have a mild Alzheimer's disease, which is less than 18 points, and therefore standing of average is about 9 plus or minus 5. Therefore, endpoints are 13.5 for the control group and 11 for the experimental group. In the program, the G-Power, I used a mean of difference between two individual means. The type of power was an A priori, and it was one tail, and the effect size was 0.5. Once I plugged that in to the information, there was 59 per group minimum. And the recruiting was 65 per group because people drop out or they get sick. To conclude this, possibilities of problems that occur are patients might drop out because they're sick. Medical comorbidities could affect the data. Keeping the study double-blind is impossible due to physical food being presented. Patient safety is considered. We're going to de-identify patients' information for confidential reasons, making sure that the patients understand that they're participating at full consent. So we'll test them every week and make sure that they still understand the participation. And also the safety of medical safety. So we want to make sure that it's a safe procedure. It's nothing but blood taken or injecting them with anything. It's just changing their diets. What is our goal? The goal is to find out if the experimental group has a statistical slower rate on progression than the control group. What would this mean for science? Well, you would identify at least one non-medical intervention that can help patients with Alzheimer's disease. While gluten is not actually the cause of AD, it can help us further down the road with research. And lastly is my references that you can look up if you prefer, and thank you for your time.